Kouška? One, two. It's working.
Hello, welcome our next speakers, Petr, Hráček, Michal, Ruprich and Josef Řídký. They will be talking about remote dependency solving.
Hi folks, I'm glad that you attend this presentation. I see many of the RPM specific guys like Florian Festi, Petr Písař. Well, let's start. We will talk about the project remote dependency solving. Sorry, I have to walk. I feel better. Well, what is the agenda? First of all, we will introduce the project itself. We will talk about the project deeply, and afterwards, my colleagues Josef Řídký and Michal Ruprich will talk about the deep implementation like client, server, and whatever we want. The colleagues are pretty nervous about the questions. Please ask at the end. No, seriously. You can ask whenever you want. Well, I would like to speak about who was initiator of this project. The initiator of this project was Jan Zelený, and he left this presentation 2 minutes ago. Well, the project itself is a part of Red Hat Lab QE. It means that there are several projects. Nowadays, on the project works 3 students. Michal, Ruprich, Josef Řídký, and Šimon Matěj. Šimon Matěj, I guess it's not here. Well, what does the project aim for? Let's imagine that you have low-cost devices like smartphone. Who knows what does it mean, smartphone? Yeah, cool. At least 2 people. And you install the Fedora. As I said, let's imagine. And you would like to install the package. What do you want? You want to install. You need to install. You want to find the dependencies and install the packages. Sometimes, 99%, the memory is completely consumed and the dependency fails. Well, and the device completely does not install anything. Well, and this is the aim for the server-side dependency solving project. Basically, it sends the data to server solves the dependencies, returns the answer to client, and client install without any crash. That's awesome. And this is the turn for Josef.
So Peter, thank you for your introduction. Hi, I'm Josef, and I will tell you something about the project, and I will tell something about the client application. So, project contains 2 console applications. One is for client, one is for server. Client and server communicates through network using request-to-response communication model. Nowadays, we don't have servers situated somewhere in Fedora infrastructure, so the project can run only on a local host. Something about a client. If you want to use it, you should know this. Client sending only request to server. For sending request, we are using JSON structure in communication. Client does not solve any dependencies, and this is the most important thing on this project. Client is here just for the download, install, update, or erase packages. For downloading, we are using a librepo library. For installing, updating, and erasing, we are using rpm-lib library. So, how the clients work? In the terminal, you will type some command like you can see on the top of this slide. rds-client, type of operation that you select. You can choose install, update, or erase. And the list of packages that you want to install or do with the packages, the requested operation. What client do? Client will parse repo files. From repo files, we are getting just the URL address. And we add to this information type of operation and list of packages that you typed in a command. All of these informations are sent to server. To server, we are as well sending two more files. First is system-solve, and the second is yamconf. Both of these files are important for the dependency solving. When the server has all of this information, the server will solve dependency and return in an answer the result of the dependency to client. The answer can contain three types of information. First is a list of packages that we will install and with which we will do the requested operation, so install, update, erase. Second type of information is error message. This means dependency error, that dependency cannot be solved from some reason. And the third type of information is that it's nothing to do. That means that all the requested package that you type are already installed, so nothing to do. Second part of the project contains the second console application. It's a server, and Michal will tell you something more about it.
Okay. Test. Does it work? Okay. My name is Michal, and I would like to tell you something about the server-side operation. So, as was already said, the server only does dependencies, nothing else. It does not install anything. It only solves the dependencies. For solving, we are using Hockey library, and for downloading some metadata about repositories, we are using the librepo library. So if we initiate the server, as Josef has already said, we need some information from the client. So we need three types of information. We need the links to all the repositories that the client uses. We need the system-solve file, which is basically a collection of all the packages that the client uses. And we need, of course, the information about the requested packages. So the server uses the librepo library to download the metadata about the repositories. Then it creates a sec object, which is basically, again, it's a huge collection of packages. We fill the object with all the packages that are available in the repositories and all the packages that are available on the client. And with the information about the requested packages, we solve the dependencies. The result is some answer that is sent to the client. So now we would like to show you a short demo. So first, there will be the install operation. So first of all, we check if some package is installed on the system. For example, Emacs. It's not. So we initiate the server, and from the client side, we try to communicate with the server and try to install the package Emacs. Okay, so we can see that there is some communication going on between the two applications, and the server is counting the dependencies. Here, there is an example of the JSON structure that we are using as a communication tool. We can see there is some state code, very similar to, for example, HTML, just to indicate what is going on the server side, on the client side, and so on. And the answer from the server is basically the Emacs package, the link to the repository, and the location on the repository. On the client side, again, we can see that there is only one package that will be installed. And of course, there is this prompt for the install operation. So we initiate the prompt. Okay, we want to install the package. You can see that it has downloaded successfully and the package is installed. Now if we check with RPM that the package is installed in the system, it is already there. Okay. So next there is an erase operation. So again we check if the package is installed. Yes, it's in the system. So we initiate the server, and again we try to communicate from the client side with the server, and we request that the package Emacs is erased. So we initiate the erase operation with the Emacs package. Again, the dependencies might take some time, of course. And the answer should be, again, just one package from that should be erased. Here we can see that the metalink is actually a system file, which means that which indicates that the package was already installed on the system, because the system file is the source file that I mentioned before. So again, for Emacs we need to erase only one package. So if we initiate the erase, we press yes, the package will be removed, and now we can check that the package really doesn't appear in the system. And there is a third demo. We would like to show you that we are actually able to update the whole system. So we simply, we don't specify any packages, we simply initiate the update command. Again, the dependencies take some time, and the answer is a huge list of packages, because I actually haven't done the update for some time for purposes of this conference. So you can see that there are like 560 packages that should be installed or updated. Yes, there is some should be installed, some should be updated, and 2 should be erased. Now, of course, now in the prompt, I will only press no, because I really don't want to install anything. So never mind. So this is a short demo that should demonstrate how the program works. Now, to sum it up, so the client provides some information about its system. The server solves all the dependencies, and the answer or the request is sent in the JSON format. So maybe you noticed that it actually doesn't do anything new apart from DNF, but this is just the current state of the application. There are some future plans that we are aiming for. Of course, we need to secure the communication, because the client is revealing a lot of information about itself. The security is prepared. It's just that we still don't have any server or anything, so we the security part is actually turned off in the application right now, because it only runs on localhost. We are hoping that in a few months we will be a part of Fedora, so it will be a package on Fedora, and you will be able to download it and install it and use it. Of course, we are hoping that we will be able to try this application on a real server as some kind of a daemon, and anyone should be able to use it just with the client-side application. And then there are 2 main points that we are aiming for. There is the client database and the caching of solving problems or operations. So for the client database, if we initiate the client for the first time, we need to send a whole lot of information. The biggest problem is the solve file, because it could be really huge. we would like to create a database of clients, and if there is a client who already tried to connect to a server, and the solve file is on the server already, the client doesn't need to send it. So we are aiming for decreasing the amount of information that should be sent through the network so that there is as little as possible. The second point is caching solving operations. We would like to, let's imagine a situation where a client requests, for example, from the demo, requests installment of Emacs package. Then there is a second client who has the same collection of packages installed on the system. So it is basically the same copy of the Fedora system right now, and it requests the same package. So there is basically no need to repeat the dependency solving operation. We can simply just use the answer that is cached from the previous operation and just send it to the client. So these are the two main points that this application should aim for.
Well, and at the end, I would like to speak about other future plans. Nowadays, the rebate server-side dependency solving is not a part of Fedora infrastructure, of course, because the project works 3 students, and they do a really great work. And we would like to introduce the project to the Fedora infrastructure soon. Who of you knows Red Hat Satellite? Great. Let's imagine that you have a farm which counts, I don't know, 10,000 computers. You will update the first one, and the rest of the computers are only installing, like Michael mentioned, caching solving. It saves time. And of course, the project can be solved in Fedora workstations. Why not? This is not only for the low-cost devices. And this is the conference. This conference is about the bingo word, with Docker. And let's say that you have the one Docker file and you would like to install it. Some package, like, I don't know who I can send, Petr, yeah. And you will install the first Docker image via our software. The second Docker image would like to install the same. And it was already installed, no dependencies are needed, and it is installed immediately. And the rest of the features which comes from my memory can be introduced later on. Well, where you can find the project? On the GitHub. Oh, typo. This is not the reference I can show you. Who are contact of this project? My 3 students and me. And blogs and articles about the project will come in soon as on the Fedora and as for on the developer Red Hat. Well, I guess that's all. It's a pretty short presentation. Yeah? You did not run? Why? Well, please, questions? From the list.
So the basic question, you mentioned that the solve file can be quite big and you don't want to translate it over network. So my question is, what does this file contain? Because I just tried running rpm-qa through gzip and it's like 32 kilobytes. So.
Okay, thank you for the question. Well, the file is basically, as I said, a collection of all the packages installed on the system, on the client, okay? And it's some kind of a binary file. And for example, I don't know, maybe that you have some new copy of Fedora, something like that. Because for example, my solve file is like 4 megabytes big. And there might be solve files that might be like 100 megabytes, 400 megabytes big.
That's why I'm asking what it contains. Because from my point of view,
to be honest,
all the server needs is the output of rpm-qa, which lists all the rpm packages installed.
to be honest, I'm not really sure what it contains because it's a huge binary file that is actually created in libsolve.
Florian.
Maybe it's not a good idea to send that over network if you can send something small.
I can answer that. So it's basically the part of the RPM headers which are relevant for dependency solving in a compressed binary-only format.
Yeah.
So the thing is, why that's needed, the problem is if you only have packages from your own repositories installed, you can get away with just sending the names or the hashes or the IDs of the packages. But as soon as you have third-party software installed, the server cannot know the details of those packages. And they are basically contained in the source file. So the server can be sure he does know about all the other packages you have in your system.
And the source files.
So with every package, it also contains the information from where it came from?
Yeah, it basically contains all the dependency stuff from the packages.
And from what I understand, the source file is actually like a huge binary, let's say logical equation. The system is using it to solve the dependencies. It actually uses the whole binary file to solve this equation with the requested package. And if the answer is 1, true, then the package can be installed. So.
The thing is, it's probably worth trying to send a list of packages first, check if they can all be found in the repository, and then reassemble the source file on the server side to avoid shipping. But of course, this can fail if you have packages which are not known in the repositories. But that's probably something I would try before all the other stuff.
Yeah, thanks. And
It assumes that they're all part of the repository.
Bottom line is it's certainly not enough to just send a list of names because there will be some inconsistencies related to rebuild.
well, thanks. Sorry, guys. Another question?
Yeah, I was wondering if you've done work on figuring out or recommending to the client whether additional repos should be enabled to accomplish the client's wish. That becomes more relevant, I'd say, in RHEL, where there is all these different repos that have different pieces of software.
Good point.
Yes. Thank you for the question. Yes, we talked about it. It's not mentioned in the future, but we suggested it some time ago that, like you said, for example, if I request a package that is not present in any repository that I'm using as a client, and the server, of course, the server has a lot of clients, so it knows basically every possible repository there can be, because it knows a few repositories from this client, a few from this client, and so on. So yes, in the future we would like to store all these repositories somewhere else, for example, like away from the client database. And if the client requests a package that is not available through his own repositories, then the server will, as you said, assume that maybe he should tell the client to first allow this repository and then try to request it again. Then it will be solved.
Okay. Another question?
Basically about searching. Do you have plan to have support for searching? Like, I don't know the package name. I just want to install more site packages.
I guess that this is the correct...
Because like, there's another reason you have to do metadata, because you want to search for stuff. And if the server can satisfy the search, it would be useful.
This is a really good point because Michael solved it, let's say, 1 month ago.
Did I?
Like VI.
Let me think. Yes, the search should be there. Actually, we were trying to do it before the conference, but we had exams and so on. We were out of time. But the server should somehow do the same operation as DNF does. So it should try to find the best possible form of the request. Like, I don't know, if you request, right now I don't have an example in my head, but yeah, of course, it should try to assume what the client wanted, if this answers your question. Or if you mean, like, the search operation that, for example, DNF allows, this is also, it should be there, of course, yes. Because the whole application should do the same stuff as DNF does, plus something that we mentioned apart from DNF, and just do it on the server side. That's it.
So like another idea, basically like you implement something like push support, because you are solving the stuff server side, so you know that this system, for example, has vulnerable packages. So unlike a normal system, until you don't know you are vulnerable until you update metadata. In this case, you could like tell all the systems that are vulnerable to update in the cluster or whatever.
Well, that's a very good idea. We actually haven't thought about it. Thank you. I think that it's
this can be implemented,
of course.
Why not? You.
So you said that you are also aiming for the embedded devices, so like a small one.
Yeah.
Do you think about some snapshot feature inside it? Because, for example, with YAM or DNF, I can use the ButterFS plugin, I think, that before the update, the tool does ButterFS snapshot, and if something goes wrong, I can just go back to the snapshot.
No. Nowadays, no, and we don't have a capacity for it. It is a really complicated, of course.
Well, it's not. If you are using the correct file system, then it's just one call.
My answer for that is really simple. I am waiting for your pull request, who will implement it. But as Michael said, we do not want to introduce the new features. Basically, first of all, we would like to solve the problems like DNF, install the methods and so on and the rest of the stuff. We do not want to duplicate DNF. I don't know if we will introduce the project as a plugin or as a standalone. This is not nowadays in the time frame out. We will see.
So eventually, this could end up being part of DNF, right?
No.
Why not?
They don't want us. I don't know. It's just that I think that we just haven't talked about it yet. It's just like
It's the other way around, so you should talk to them.
Florian?
So I have a remark. Can you please change the command line interface to be the same as DNF?
Yes. Yes, this is my proposal to colleagues to change it, of course. Yeah, it will be soon because... Sorry.
Second thing is, have you any numbers on how much resources you are actually saving? Because the thing is, it's very clear you're saving downloading the metadata, which is a big thing. I get that. But running the RPM transaction typically is bigger than running the solving. So I have doubts that you actually save resources on the device with that.
But I think avoiding that download is huge. If I have a lot of repositories enabled, the metadata download on a VPN can be 10 minutes.
I'm not arguing with that.
Sorry, guys. Florian, I know what are you talking about, but the basic idea was about this dependency solving. And it's complicated to answer.
I might add something. I think that right now we don't have sufficient data to measure this top, like to measure if we actually saved some time or not.
No.
Because we are actually using it on our own machines, and we don't have any embedded devices that we could use. We don't have a server that we could use. So I understand.
Just do the measurements.
Yes.
Because my guess is you will have a hard time actually saving like CPU or memory.
Yeah. I did it, some tests. Like you mentioned, I made an update, the Fedora 23, I guess it was, after, let's say, a month. And on my workstation, it took 10 minutes, 20 minutes. And I made a snapshot. I tried to do a solving on the dependency side, and it really saved 5 minutes time for me. Yeah, it saved the time. But it is a proof of concept. I heard that something like this is already being solved in Red Hat, but I have to clarify it.
So, for clarification, so it took 10 minutes to solve the dependency?
Yeah. On my Fedora workstation 23, 2 weeks ago, I tried to install or try to update the system, and solving took 10 minutes.
But with DNF.
Sure.
Yeah.
Okay, so is there actually any reason why it should take that long? Like
Yeah, I have, let's say, 10, 13 repositories, and downloading metadata, updating, solving, it really took a time. So much time, yeah. But, I don't know.
I'd like to offer another point of view, right? I've been using Debian for ages. It never took that long, just for...
Yeah. Why not?
Yeah. So what?
I don't think that it is something wrong to the DNF.
Well, I'm not sure
I would like to
if, it could be easily put like that Debian does something wrong because it takes less time. But it's
I only can say contact DNF. What is wrong? What is the pain?
But if I may rephrase or really put it into question, isn't it better then, to work on optimizing the dependency solving algorithm so that it
definitely
doesn't take that long?
Yeah.
The dep solve's pretty cheap. It's the metadata size. The size of the SQLite database is large. There's a lot of metadata. I think the Debian counterpart just doesn't have as much content in the metadata store.
Debian has differences.
Guys, sorry.
It's on dependencies, not file dependencies, so their metadata is smaller. But
as far as I know, Debian just checks package names.
Yeah.
Exactly. So RPM does a huge step forward because, for example, we're using library so names instead of names.
Right.
So we do less repeats.
Even DNF install path.
Okay, sorry guys. Another question. Sorry guys.
That was a good point. So, my question would be, what is the benefit of using this instead of using something like OS3 and building the whole package set, really installing the packages on the server and then downloading just the image or the snapshot of the image as Atomic Host does? What does this bring differently? Like if I have a MIDI device, I probably want to install image, not install a single package. I want to be sure that the operation of switching to new version is Atomic and stuff like that. So, what is the benefit?
The benefit is only from the project itself is about the remote dependency solving and to teach students how to connect to the Red Hat network. We are not talking about what is another project like OS3 and other. We would like to, I don't know if there are any differences, if there is any benefit or whatever.
I could try to answer that if that's okay.
Yeah, no problem.
You can install what you want here.
Yeah, you can try to. If you are in control of the OS3 server, then you can just build instead of you can send their package set a request the image, and it will install for you the image on the server, which is basically the same operation.
Yeah, but the key difference, in my opinion, is that in this case you have frozen package set, but like this you can install any package quicker.
And you don't have to wait for somebody to create an image.
Yeah.
No, it's just about automation, right?
Yeah. And
okay.
And if I may, I'm not really sure, but wouldn't the image be much larger than just the answer from the server?
Right, but
like the client would need to download from the server the whole image. This is just few bytes of answer, and then you can download and install.
You are installing the packages anyway.
Yeah.
Yes, but
then you would just download the update of the image, for example.
Yeah.
So
okay.
It's the amount of data from my point of view is the same.
Okay.
It's just that you are doing different things. But I was interested in.
We have 5 minutes left. I would like to last question if you have.
So maybe a small one. I think if I prepare an update of some package, I can specify that this update requires a reboot of the machine. Do you count that in your?
No.
Not really. Not right now.
Well, last question, please.
Do you have any plans
Give me a moment, guys. Huh.
Who wants to use this doesn't have to run the CLI too.
Yeah, but I've never. Yeah, good point. I see that we never talk about libhiv. Like Richard Hughes introduced, this is some composition with librepo, Hawkins, and stuff. I had a discussion with Richard Hughes 2 hours ago, and libhiv does not allow you to only install the packages. Yeah. And that's all, and we cannot use them. But we can provide the API. Yeah, why not? Because this is the project, and this is not the reason why we should not provide. I agree, we can.
Yeah, that'd be nice.
Sure. Thank you, guys, and I would like to thank to my colleagues.
Test.